Hello everyone, in this video I'm going to give a detailed explanation of problem C from CodeForces around 1096 div 3. If you want to see more content like this, please like and subscribe. Yusef has been given you an array of A of n positive integers. Let f at A denote the numbers of subarrays of A whose product is divisible by 6. Our task is to reorder the elements of the array A so that f at A is minimized. If there are multiple ways there, it's okay. So we are given an array A, and we must reorder the elements such that the number of subarrays, a subarray is basically a contiguous part, or like this, or this, or this. These are all subarrays whose product of the elements of the subarrays are divisible of 6. That's fa. But if we want fa to be minimized, we have to have the most possible subarrays that are not, whose product are not divisible by 6. So the first observation is that a product or a number is divisible by 6, a product with p, only if product is divisible with 2 and with 3. We can divide this problem into parts. For every element that is divisible by 2, we can store it in array A. Then for every element that is divisible by 3, we can store in array B and in C that are divisible by 3 elements from A. And D, the elements that are not that don't satisfy any of those conditions. We can say the generic elements in this problem. Using this, we can solve our problem pretty easily, because you want the minimum number of subarrays or contiguous parts. We have to A and B should be as far as possible. So, for example, if we get this array 3628, 3628 A will look like this. 228 B will be like this, and then let's add another number that will be in D. C will look like this, and D will only contain the number 5. So if we put them like this, so we want A and C to A and B to be as far as possible, because if they're as far as possible, that means that every contiguous segment it's not divisible by 6. So you maximize our f at a, minimize, sorry. So if you put this, if you concatenate those vectors in this order, so a, then because we want a to be as far as possible from c, from b, we can put b at the last position. Then if we put d here, it's perfect because now there's a bigger distance from between these two, and because the array C destroys every array, we can put it or before B or after B, it doesn't matter, so I'll just put it right here. And now, for example, if we put this like this, 2, 8, then 5, then 3, then 6, we know that every array from that starts here is good until we get to B. So this is good, this is good, this is good, and then again this is good. And now because we've reached this part, there are no more arrays to count except this one and this one, because they don't contain 2's. Using this, we can solve the problem in O(n) and have our rearranged elements that fit the criteria like this. This will always give us, this arrangement will always assure and always be correct, because we can form more arrays that fit the requirements, actually the maximum number. So if I go in C++, we can solve this problem in O(n). So we have our arrays. And if all of, so let's now form them. Compute. A, it's only with elements divided by, that are divisible by 2. So if x is divisible by 2, we can actually start the other way. So if x is divisible by 6, then we've already put it in C. Else if x is divisible by 3, B push back x. Else if x is divisible by 2, we have A push back x. Else, because this will be a genetic number, we can put this in our generic. And using this, we can just print the new arrangement. So in our order, it's like this. We first print A, then D, B, and D. A, D, B, and C, sorry. B and C. Extremely sorry. C, it's C. So A. Then we print D. We print D, then B, and then C, and let's try with the example. Okay, so we have to clear those arrays. Just put it right here and it should work. Okay, so those are, we can print any answer. Remember this. And now, if I sum miracle, oh, this is the other problem. Sorry. This one. Yes. So, thank you for watching. And if you find the video helpful, please like and subscribe. Remember, if you did not understand any topic or didn't understand my explanation well, please leave a comment. I will try to answer as good as possible. See you next time.